Hello everyone. In this video, we'll learn about half-range Fourier series. Now what's this half-range Fourier series? A half-range Fourier series is a Fourier series defined on an interval instead of the more common, with the implication that the analyzed function should be extended to as either an even or odd function. This allows the expansion of the function in a series solely of sine or cosines. Let me elaborate. If a function is described over half the range, say 0 to L, instead of the full range from -L to L, it may be expanded in a series of sine terms only or of cosine terms only. The series composed is then labeled as half-range Fourier series. The Fourier expansion of the periodic function f of x of period 2L may contain both sine and cosine terms. This you have already seen in Fourier series module 2. So you have already discussed about the Fourier series in the full range form along with even and odd concepts. So you all are familiar about Fourier series and the even and odd nature of the functions. To obtain the Fourier expansion of f of x in the interval 0 to L, which is regarded as half interval, definition can be extended to the other half in such a manner that the function becomes even or odd. This will result in cosine series or sine series only. Now, what's the formula for sine series? The Fourier half-range sine series in the interval 0L is f of x equals summation 1 to infinity bn sine n pi x by L. How to calculate bn? Using the formula 2 by L integral 0 to L f of x sine n pi x by L dx. Now how about cosine series? Fourier half-range cosine series of f of x in the interval 0L is given by f of x equals a0 by 2 plus summation 1 to infinity an cos n pi x by L. How to calculate a0? Using the formula 2 by L integral 0 to L f of x dx. And what about an? An equals 2 by L integral 0 to L f of x cos n pi x by L dx. Now, do you remember this formula? Have you seen this anywhere? Yes. When you have seen Fourier series, you have discussed about the even and odd nature of the function, and this formula you have seen when you have written for the even function, and the sine series formula you have seen for the odd nature of the function. So here I can say sine series is an odd series, cosine series is an even series. So that will be easy for you to remember if you compare and learn. Okay, so Fourier series even and odd nature formula you have written. Along with that, you can connect this sine and cosine series in such a way that sine series you remember the odd formula and cosine series you can remember the even formula. Okay. Now, so here we have discussed regarding 0 to L and what will happen if your interval is 0 to pi. When your interval is 0 to pi, you need to just replace L equal to pi. So let me put here L equal to pi. Then what is A0 formula? So when you put L equal to pi, your A0 formula will be 2 by pi integral 0 to pi f of x dx, and An formula equals 2 by pi integral 0 to pi f of x cos n pi x by, put L equal to pi. When pi cancels, this formula reduces to f of x cos nx dx. So this is the way we can incorporate the value when L is pi. Now let us see problem. Problem is expand f of x equal to x into pi minus x as half range sine series over the interval 0 to pi. Solution. As you have written the sine half range series, and I have already discussed that you need to replace L by pi. So f of x equal to summation bn sine nx, because it was like sine n pi x by L dx if the interval is 0 to L. When you put L equal to pi, your pi cancels and you will be getting sine nx. Bn equal to 2 by L integral 0 to L f of x sine nx. General formula. Now when you put L equal to pi, you can see that L is replaced by pi and integral 0 to pi f of x. What is the function here? Function is x into pi minus x. When you multiply, that becomes x pi minus x square. So here I have given x pi minus x square into sine nx dx. Now how will you integrate this? We can integrate using Bernoulli rule. What's Bernoulli rule? Integral uv dx equal to u v1 minus u dash v2 plus u double dash v3 minus etc. What is this v1, v2, v3? They are successive integrals. U dash, u double dash etc. are successive derivatives. Here what is u and what is v? U is x pi minus x square and the value of v is sine nx. So let's integrate. 2 by pi u v1. U is nothing but x pi minus x square. v1 is the integral of sine nx. What's the integral of sine nx? Minus cos nx by n. So if you have just sine x integral is minus cos x. Here you have sine nx. The integral of sine nx is minus cos nx by n. Like if you have sine ax integral will be minus cos ax by a. So in place of a you have n. Minus u dash. What is u dash? U dash is the derivative of u. Where is u? U is x pi minus x square. So what's the derivative of x pi? It's pi minus derivative of x square is 2x. Then you have v2. What's v2? v2 is the integral of v1. Where is v1? v1 is minus cos nx by n. So what's integral of cos? Integral of cos is positive sign. So you can see that here I have written positive sine nx by n. Already we have one n into n, which is n square, and with the negative sign which I have already written in v1. Next sign is plus in Bernoulli rule. So plus u double dash. U double dash is the derivative of u dash. What is u dash? Pi minus 2x. What's the derivative of pi? 0, and derivative of minus 2x is minus 2. Derivative of constant is 0. Here pi is constant. So we have written derivative of pi is 0 and derivative of minus 2x is just minus 2 into v3. What's v3? v3 is integral of v2. And what is v2 here? v2 is minus sine nx by n square. Now what's integral of sine? Integral of sine is minus cos. So minus minus goes to plus. Hence we have written plus cos nx by, since we had n square into 1 more n you will get when you integrate, that becomes n cube. And the value you have to put from 0 to pi. When you put the value x equal to 0 and x equal to pi, you will be getting 4 by n cube by 1 minus 1 power n. Sine n pi is 0, sine 0 is 0 and cos n pi is minus 1 power n. That's why you are getting the value 4 by n cube pi in brackets 1 minus 1 power n. Now we need to put it in the expanded form. F of x equal to summation 1 to infinity bn. Bn value we have written 4 by n cube pi into 1 minus 1 power n into sine nx. This is the solution for the function f of x equal to x pi minus x as a half range sine series. Next problem. Obtain the cosine series of f of x equal to x from 0 to pi by 2, pi minus x from pi by 2 to pi over 0 to pi. Since we have discussed about the sine series, each step, here you can see I have displayed the solution altogether. Just go through it. F of x equal to a naught by 2 summation 1 to infinity a n cos nx. So a naught by 2 plus summation 1 to infinity a n cos nx. When you have 0 to L, it was cos n pi x by L. Since we are replacing L by pi goes and you will be getting cos nx, which we have already discussed when I have written the formula. A naught value 2 by L is 2 by pi here. Integral 0 to L is replaced by 0 to pi f of x dx. Now just have a look at the function. 0 to pi function is divided as 2, which is x and pi minus x. So 0 to pi by 2 is x. Hence we have to split the integral as integral 0 to pi by 2 x dx plus integral pi by 2 to pi function is pi minus x into dx. Let's integrate this. What's the integral of x? Integral of x is x square by 2 and put the value 0 to pi by 2. And the other one pi minus x dx. Pi into integral of dx. Integral dx is x minus integral of x. What's the integral of x? X square by 2 and value pi by 2 to pi. When you put all the values, lower limit 0, upper limit pi by 2 and expand, you'll be getting value for a naught as pi by 2. Now how to find an? An is 2 by pi integral 0 to pi f of x cos nx dx. So we'll be writing f of x 0 to pi by 2 as x function and the other one pi by 2 to pi as pi minus x into cos nx dx. Again, make use of the integral formula and reach this step. Putting the lower limits and the upper limits, you will reach here. Once you got the values, minus 2 by n square pi 1 plus minus 1 power n minus cos to n pi by 2, you will be putting the values n equal to 2, 6, 10, etc. When n is 2, minus 1 power 2 is nothing but 1. So 1 plus 1 is 2. And cos n pi by 2, when you put n equal to 2, you'll be getting cos pi, and value of cos pi is minus 1. So minus 2 into minus 1 is plus 2. 1 plus 1, 2. 2 plus 2 is 4. 4 into 2 is 8. Hence, minus 8 by n square pi. Now, as we have done in the last problem, we are putting it in the expanded form. F of x equal to a naught by 2. Then plus summation 1 to infinity. A n into cos nx you have written. So 8 by n square pi into each value n equal to 2, 6, 10, etc. Replace all the values of n by 2, 6, 10 and get the expanded answer. This is the end of the session. Thank you everyone.